Good morning, children. Today we are going to start our section by the topic states of matter from the lesson matter. Those who have the book, please take your book. Those who don't have the book, please go through the video carefully. There are three physical states of matter. Okay, solid, liquid, and a gas. For example, steel is a solid, oil is a liquid, and air is a gas. There are three states of matter: solid, liquid, and a gas. Many examples are around us. We just observe it. And here it is given: steel is a solid, oil is an example of liquid, air is an example of a gas. The state of a substance can be changed by changing its physical condition, such as temperature. The state of a substance can be changed by increasing or decreasing the temperature. Water, that's a familiar example. Water can exist in three states: ice, water, and steam. Ice is in solid state, water is in liquid state, steam is in gaseous state. Solids are rigid. They have a definite size and a definite shape. Solids are rigid. Solids have a definite size and a definite shape. Solids are very tight. Each and every solids have its own size and shape. But same time, liquids are not rigid. Liquids are not rigid. They have a definite volume but no definite shape. They take the shape of the vessel in which they are placed. The shape of the liquid, that is the shape of the vessel in which the liquids are placed. Gases are also not rigid. They have neither a definite volume nor a definite shape. Gases do not have a definite volume nor a definite shape. They take the volume and shape of the container. They take the volume and shape of the container like liquid. The properties which decide the state of a substance, that means solid, a liquid, and a gas, are, there are three properties. There are three properties. First one, it is intermolecular space. Intermolecular space. Second one, force of attraction between the molecules. Then third one, kinetic energy of a molecules due to their motion. These are the three properties which decide the state of a substance, whether the substance is a solid, liquid, or a gas. First, we are going to discuss about the solid. When intermolecular force is very strong, the kinetic energy is very less. The intermolecular space is reduced and matter exists as a solid. In a substance, the intermolecular force that is very strong, then we can say that those substance is in a solid state. In a solid state, the intermolecular space is very small, and same time the intermolecular force between the constituent molecule in a liquid, that is not that much strong, and the kinetic energy is sufficient for the molecules to move to and fro. The intermolecular space is increased and matter exists as a liquid. In a liquid, the intermolecular space, that is a little far, and intermolecular force is little weak comparatively the solid. That's why the liquid have its own state liquid. Then now gas, when intermolecular force is negligible and kinetic energy is very high. In a gas, the intermolecular force, that is negligible, and that's why the kinetic energy is very high. The molecules can move here and there in gas. That is why the matter exists as a gas. Its intermolecular force is negligible and the kinetic energy is very high. That's a gas. A gas exists as a gas. Now we are going to discuss the topic molecular model of solids. Each solid is made up of very tiny particles called molecules. These molecules are very small in size and they can be assumed to be like tiny rigid balls. Each and every solid is made up of molecules. Molecules, we know that is very small. We cannot see the molecules. We cannot see the molecules by naked eyes and even microscope also. These molecules are very small in size and they can be assumed to be like tiny rigid balls. And second point of molecular model of solid, that is the separation between two molecules in a solid, that is very small. The separation between, the space between the molecules in a solid, that is very small. The molecules in a solid can only vibrate. Third point is the molecules in a solid can only vibrate about their mean positions. It cannot leave their positions. It can vibrate in their own positions, it can vibrate, but it cannot leave their positions. Fourth point is the molecules in a liquid are closely packed due to the strong attractive forces between them. Here is the one diagram, figure 1.4. By this diagram, you just observe the diagram, you can see the arrangement of molecules in a solid. See the diagram, okay. Arrangement of molecules in a solid. The molecules are very tightly held. It cannot move from its own positions, can vibrate. Thus, the molecules in a solid are in a fixed positions. Due to the strong intermolecular forces, they do not have their positions. They do not leave their positions. Due to the strong intermolecular forces, they do not leave their positions. So, a solid has a definite shape and a definite size. The molecules cannot leave their positions, their particular positions. That's why solid substances has a definite shape and a definite volume. Now we will discuss Molecular model of liquids. Solids we have discussed. In liquids, each liquid is made up of very tiny particles called molecules. Like solid, these molecules are very small in size and they are not in a rigid arrangement. In a liquid, the molecules are not arranged that much tightly. It is not arranged in a rigid arrangement. It is not arranged in a rigid way. Loosely arranged. Second point, the intermolecular spaces in liquids are more than that in solids. The intermolecular spaces in liquids are more than that in solids. Third point is, the liquid molecules can move about freely within the boundary of the vessel in which the liquid is kept. The liquid molecules can move very freely within the boundary of the vessel in which the liquid is kept. Fourth point is, the molecules in a liquid are less closely packed and their positions are not fixed, as they are free to move within the boundary of the vessel, as shown in figure 1.5. In figure 1.5 you can see the molecular arrangement of liquids. It is loosely arranged. The molecules in the liquids are arranged loosely. Thus, the liquid molecules can slide over one another, due to which a liquid can flow. The intermolecular forces, although weak, are sufficient to keep the molecules within the boundary of the vessel. So, liquids do not have a definite shape, but they have a definite volume. Liquids do not have a definite shape, but they have a definite volume. Why? The intermolecular forces, although weak, and are sufficient to keep the molecules within the boundary of the vessel. That is why liquids do not have a definite shape, but they have a definite volume. Now we are going to discuss about the molecular model of gases. Like solids and liquids, gases are made up of very tiny particles called molecules. Okay, these molecules are very small in size and they can be assumed to be like non-rigid balls. Okay, then second point, the separation between the molecules is quite large as compared to that in liquids and solids. The separation between the molecule, the intermolecular space, that is large, quite large as compared to liquids and solids. Third point, the molecules in a gas can move about freely in space available to them. The molecules in a gas can move very freely. Fourth point is, the molecules in a gas are wide apart. The molecules in a gas are wide apart and their positions are not fixed. In a gas, the position of a molecules, that is not fixed, because the intermolecular forces between in them are very weak. The arrangement of molecules in a gas is shown here in the diagram. See, just observe the diagram. See, it's too far. The molecules are arranged too far. It can move here and there. That's why we are discussing the molecules in a gases moves in a zigzag motion. Okay. Thus, the gas molecules are quite free to move here and there and the space available to them because of their weak intermolecular forces. The molecules in a gas arranged very freely, very far. That's why the intermolecular force in gases, that's too weak, that's very weak. That is why the gases have neither a definite shape nor a definite volume. Okay, today we are going to wind up our class by this point. I hope you all are understood. If you have any doubts, you can ask to me by messages. Okay. Then one more thing, you have to read the chapter or see the video 2-3 times to understand the chapter. Learn carefully. You please write and keep important points in a rough copy, and please concentrate in studies. Stay home, stay safe. Then till next section, next video, goodbye.